Hey everyone, so today we'll be talking about this lead code problem, find first and last position of element in sorted array. So you are given an array of integers nums sorted in non-decreasing order. Find the starting and ending position of the given target value. So if the target is not found in the array, then you need to return -1 comma -1. Okay, and you must write an algorithm with O log of n runtime complexity. Okay, so basically when we are told that this is a sorted array, and then we need to find something, basically we'll go with binary search. Okay, so over here if you consider this example, we have this sorted array. Our target is 8, and the first position of 8 and the last position of 8 are at index 3 and 4. Okay, so uh, let's just consider this example. um, let's say we have this array, 2 4 6 8 8 and 10. Okay, and these are the indices 1 2 3 4 5 6 and 7. So we need to find 3 over here, and we need to return 6 if our target is 8. So we'll be doing a binary search, but what we'll be doing is, uh, if we do a binary search and we look for a target, let's say we get this 8. Okay, but uh, what are the chances that we would still have some 8s towards the left? Okay, and also we need to also find all the last 8 towards the right. Okay, over here like this. So we have to call this binary search two times. One to find the leftmost target element, and to find the rightmost target element. So what we'll be doing is we'll be calling a binary search once over here. Now the moment you found the value, we are not supposed to stop. We are still supposed to continue towards the left in this situation. Why? Because chances are that we'll still get this target value towards the left of what we have found. Similarly, when we look for the when we run a binary search on this target 8, we'll get some index. We'll say, okay, let's say we get that on the fourth index we found the target 8. But not necessarily this is our rightmost element. We still need to go towards the right till we get this last element over here. Okay, so what we'll be doing is, the moment we are going to run binary search individually to find the leftmost and the rightmost element. Okay, so let's just write the code for this and see how it works. Okay, so let me just write the boilerplate for this first. So let left left position is equal to, let's say some value 0, and let right position is some value 0. So what we need to do is we need to return left position comma right position. Okay, so this is going to be our answer. Okay, for this we'll be writing a helper function binary search. We will be passing nums array, we'll be passing a target, and we'll be passing a true and a false value, and I'll tell you what is this true and false value later in some time. Binary search, we have nums, target, and false. Okay, so basically this third Boolean value will tell us whether we need to move towards the left or we need to move towards the right. Okay, so let's just write the helper function binary search. We want the array, it is going to be of type number array. We want a target which is going to be of type number, and we want a boolean which is going to tell us whether we want to search towards the left or towards the right. This function is going to return a number to us. Okay, So let's call the write the code for binary search. So we want to have the left index, we want to have the right index, run a loop while the left index is lesser than or equal to the right index, and then find a mid value. Now, if the mid value is greater than the target, then we have to search in the left portion of the array. Otherwise, you have to search on the right portion of the array. Or we'll just write the code for it. So let left equal to 0. So this is going to be our zeroth, the first leftmost index. Let right equal to nums dot length minus 1. Okay, so now while left is less than or equal to right, okay, we need to traverse on both the pointers. Let's calculate the mid. What is the mid position? So what we say is mid is, we'll say left plus right minus left divided by 2. Okay, and in JavaScript we need to round it off. So we say math.sil. Okay, so this gives you the index uh, of the mid element in the array. All right. So now we will be checking what is the value of this mid. So now if nums of mid is less than target, okay, else if nums of mid is greater than target, okay, else we have found the element. Okay, so now what does this mean? The nums of mid, is it lesser than the target? Okay, over here, let's say our mid is 6. Is this 6 lesser than the target? Yes. So that means we have to search towards the right of the array. So that means we have to increment our left position by mid plus 1. Okay, so this means that we have to change our left position to mid plus 1. Now if the nums of mid is greater than target, that means we have to search towards the left hand side. So we have to we have to change the right position and keep the left position as it is. So mid minus 1. All right. Now we have found the target. Okay. But chances are that it's going to be there could be some element. So over here, let's say if we found a target. Okay, we found this in our first iteration. Okay. But we are looking for the left position. Okay. So we still need to go and traverse like this. Okay. And it's going to be for this iteration. Similarly for right position, okay, if you have found over here, chances are that there could be some more 8 towards the right. So, okay, so we need to go and continue looking for this target. Okay, so what we'll do is, let's initialize I equal to minus 1. Why? If we have not found the target, then we'll be returning minus 1 over here as per our requirement. So what we'll say is, we'll say I is equal to mid over here. We have found our middle element. But should you continue looking if so that is based on this condition is left. Okay. So what it means is that if is left is true, that means I want to still continue looking towards the left. Okay. I want to still continue looking towards the left position. That means what I'll say is I'll say right is equal to mid minus 1. Else I want to continue looking towards the right position. So I'll say left is equal to mid plus 1. Okay. And after this while loop is executed completely. So what happens is I found the 8 over here. Okay, let's say I found the 8 over here, but I am not satisfied. I still need to look towards the left when it comes to uh, this function. So what I do is I still update my right value over here and continue in the loop until I have satisfied this condition. And if I have satisfied this condition, I return the ith value. Let's say I did not find the target. That means I'll get -1 in my return. So I just say return I over here. So over here, uh, for the left position, I've run this loop. Similarly, I'll be running for the right position. So I'll be getting two values over here, which I written in the form of an array. Okay, so far it looks right. Let's run the test cases. Okay, so we've got an acceptance. We'll submit it. Okay, so our answer is accepted.